Welcome back, Grade 6, to Nelson Math, Chapter 5, Section 4, Solving Problems Using Logical Reasoning. Up until this point, you've been given some sort of a polygon, a shape, and you've been told to find the perimeter along with some minor exercises to do around that. However, for some types of problems, you have to use logical reasoning because you do not need the entire perimeter. This is one of those cases. The question is not going to be asking you what the perimeter is. Sometimes we get stuck in a rut, and what that means is that we try to find information that is not possible to get from the question because we're used to always looking for that type of information. So let's take a look at this question and see how we can handle it. When a rectangle's length is doubled and the width stays the same, its perimeter increases by 15 centimeters. How many centimeters longer is the new rectangle than the old one? Explain your reasoning. This problem, to be solved with logical reasoning, is really helped with a diagram. So here I have my original or my old rectangle. It's right here. And here I made a new rectangle and I put the dividing line right in the middle, this dividing line here, showing that the length is exactly double the original or old rectangle, but the width is exactly the same. Notice the width of this rectangle is right here. We don't know what that is, but for this question, we do not need it. So now that I have my old rectangle and my new rectangle with the lengths doubled, let's see if we can start to label some of this stuff. When the rectangle's length is doubled, which we did, and the width stays the same, which we did, the perimeter increases by 15 centimeters. So this is what that means. This means if we take this side plus this side plus this side plus this side, and we add 15 centimeters, we will get our new rectangle's perimeter. But let's see if we can figure out if there's any common area. So this side, side 1, and this side 1, they're the same. So they give the same amount to the rectangle in terms of the perimeter. This side and this side give the same amount to our perimeter of the rectangle. This side and half of this side gives the same length, and this side and this side give the same length. However, we don't have these lengths yet, this one and this one. We do know, though, that together they sum or they add to 15. So this side length plus this side length sums to 15. So what's the only number that can be here and here? It must be the same number that adds to 15. Could it be 10 and 5? That sums to 15. 10 plus 5 is 15, but they're not the same number. There's only one number that does that, and that would be exactly half of 15, and that's 7.5. So this 7.5 and this 7.5, when we add it to the original rectangle, that would give an increase in perimeter of 15. So let's see if we can go back here. So our old centimeter length happens to be the exact same because we doubled it. We doubled this right here. So this length is the same as this length, and it's the same as this length. So the old centimeter length is 7.5 centimeters. And once we have our 7.5 centimeters right here, we know that this is 7.5 centimeters. So how much longer or how many centimeters longer is the new rectangle than the old one? The new rectangle length being 7.5 plus 7.5, the new rectangle length is 15 centimeters, and the increase in the perimeter was 7.5 centimeters. This was all done. So now we can answer our question. How many centimeters longer is the new rectangle than the old one? 15 minus 7.5 is 7.5. So the new rectangle is 7.5 centimeters longer than the old one. And that's how we solve this problem. Have a good day, everyone.